If we complete NLP basics, Ngrams, yeah, tokenization, yeah, we already completed it. Only thing is, in this case, this one, word embeddings. Yeah, that's all. All right, let me explain this. Latent Dirichlet, there are two options, latent Dirichlet allocation and a non-negative matrix factorization. So the idea is like this is basically a part of clustering. Clustering in the sense, cluster means group. Okay. Suppose if you got data like this, data set like this, articles, wherein you don't have any target column. So if you have target column, you can train the model in the name of classification and find out which category it will come under. What if we got input data, whereas we haven't got any columns? I mean, we haven't got any target column. Then the idea is to create buckets, to create categories. Let me give you a practical example. For example, let's take that you have a lot of data in your system. You're working for a news agency. Okay, there are a lot of news in it. Just consider that each piece of news is like as one row in this case, like this. Okay, now we need to segregate into sports, politics, education, or some other, like let's take entertainment, 4 categories. So it is difficult to do it manually, right? Therein we get this thing called non-negative matrix factorization, latent Dirichlet. There are two techniques. You can use either of this, but if you want me to pick the best one, obviously latent LDA. This is the best one. Okay. Let's start with non-negative matrix one. So we have something called npr.csv. I think you already have it. So just we read the data, and as usual, this comes under clustering problem, wherein we are not going to have target column, only the input column. Okay, we have applied TF-ID factorizer here. You can use any alternative one too. And we will see the more advanced one in the next session, word embeddings. Here, we already discussed in test classification, the same thing. I have not removed any stopwords or I haven't done any cleaning part. You can add even that one too. But here I have an option right in TF-ID factorizer itself to remove stopwords. And once we have this, is what we got. Okay. Where is it? Okay, let me execute this one. Usually DTM in the sense two area, right? This will have all the data, whereas there's another one DTM. DTM not get column names. What we call it as it's not DTM. Okay, that's TF IDF. Yeah, get feature names out. So it is in TF IDF object. So here you have the call. So we can combine both the data frame. This one that is going to form a data frame article. Okay, here I need to mention columns. Here, this is the final one data set. Now we need to create NMF object here. So for non-negative matrix factorization, so it's part of scikit-learn decomposition and NMF. We need to create an object. Here I have mentioned 7. 7 means 7 topics. Suppose if you want to segregate into 4 topics. Basically, it is difficult to judge how many number of components we want to have. based on the client requirement, we need to provide it. Okay. And we need to keep on testing it. So basically, we need to keep on generating it with multiple categories, and we need to keep on cross-checking with client is just giving, at least few samples out of 10,000. Let's take 100 samples. So whether whether it has been segregated well or not, how many categories they really want, how many categories it really has. Those who write news or those who run news channels, they know how many categories that newspaper will have, right? So the same way. And in this case, once we have it, is going to display the component. I mean to say the number of based on this, it's going to create a number of categories. This we have already saw that we already prepared this data frame, right? Yeah. So once we are applying the model. Okay, not here. Um, yeah, we're fitting directly to DTM. Yeah, this is where the right DTM is all about. So we don't really require the column names, but later on we can add it. Okay, so this is where we are fitting DTM, and it's going to generate the components. And this is only for displaying it. Okay, here we have around 54,777 column names, and if you look at the column names, few, the top 10. In fact, it's not really top 10, just random ones. I can see randomly picked. So I got the random column names, right? So I can see I reran the same thing and I got a different set of column names. And when you look at this NF model components, which basically comes from this one, right? And these are all the components we got. Where is it? Yeah, these are the components we got. And of course, it may not make much sense as long as it's just values. So what we need to do is we need to do this, the NMF model components, and thereafter I combine this get feature names along with this arc sort, wherein it's going to give us, basically we are trying to go back and get the data, whatever that matches with this number. And this will give us the list of words based on the topic. Here we haven't given any topic name. So when we combine it, this is going to be like this, zeros, ones, twos, and the client has to recheck and give the category names. The client has to tell us how many categories it has. Client has to take few samples and find out whether it is clearly giving, segregating the property or not. Because this is politics and this politics. Again, this is the politics when it comes to this one. President again, okay, maybe not. So in this case, it may not have 7 or 8 categories as such. So this may not work properly. Whereas most of the time, this LDA will work perfectly well. Even if you give the same components, the same thing, there is no difference. You can give as many components as you want. There is no other difference. I can see LDA components after we fit it. And same logic at the end. Again, the same logic. It's going to, based on this, we need to find out whether it is giving the topic or name or not. This is only to showcase whether we are picking to pick the right topic name. So companies, money, year, federal, percentage, government, company, million. Basically, it means business category. Whereas this one, military, house, security, defense related topic. Whereas this one, wave, old, family, home, day, water, city, yes, food, New Year's food, just people like, most probably it is civil society or maybe for some festival kind of. Time, new, dawn, years, medical, disease, healthcare. This is healthcare. And voters, this election, right? Election, politics, music, unknown, think again, entertainment. In this case, we don't really require 7 categories. We may require some 5 or 4. So again, based on this, we can judge it. Again, we can go back and change the number of components. Here you can see this more related to education and scientific research, right? So that is how it works. There is, but LDA is more reliable one. You can even cross check that. Um, so Donald Trump is one category, updated Russian president. You can see that earlier, the previous one, it has another category altogether, but in this case, it has rated well. Whereas photography, illustration, video, it's totally different category. Join overclass and it's totally different category 3. Publicly supported debunk, yeah, public related this one. A standing by the airport exit something, so that is totally two different categories. Photography, illustration, video. I need to check the complete article. I'm not reading the whole thing. We can go and pick that particular index and check the whole text and find out whether it's right or not, even though it's not displaying well here, right? So got an idea, I believe. So this whole idea is when we don't have target column, we need to find out the different buckets or categories or sections. We can do this using, I mean, you can use the script as it is there without any change as long as it's related to text without much difference. You can easily do this. You don't require deep learning or whatever. So you can directly use this one. Any questions on this?
Yes.
I think it's better to continue tomorrow and this comes to this one because this requires a dedicated session altogether. Okay, I'll do one thing. Okay, let's finish off the rates of this one. It's not going to take much time. So count factorizer, we already saw that, right? Count factorizer basically converts text to some numbers. How many times that got repeated in that particular document. So just consider that each sentence is a document. It's going to tell us how many times it got repeated. Flower has been repeated twice. So based on the columns, you can see that it got repeated twice, right? And E's got repeated twice. You can see that E's got repeated twice, and you got 2 here. Whereas in the second one, we don't have any flower, so we got 0. We don't have another, so we got 0. Whereas we got E's, we got 1. So let's cross check it. You can see E's, right? So where the contract is simple. In fact, we have seen this earlier. So it's simple. But we can import, create an object, and fin transform that's going to give us the column names and the data. So we can combine both in create data frame. So we are not going to focus much on that. So yeah, by now you already know how to create data frame, right? And TF-IDF is much better option. I already explained this in text classification. What is the formula term frequency and the inverse document frequency? And it's basically term frequency is basically per document base, whereas IDF is overall corpus. How many documents that this particular term is being repeated, occurred at least. Let's take that it has been repeated in 20 documents out of 100, then it's going to be 20. Then it's TF-IDF is basically term frequency int multiplied by IDF is going to give us. And of course, implementation part is quite as usual. Just like the way we have count factorizer, we have TF-IDF factorizer. And this is what we got. We got much better result compared to the world one. There is something called co-occurrence vector. Counts how many often pairs of words appear together within a specified context window. So let's take a phrase, 2 words or 3 words or 4 words. How many times that it got repeated in a specific context window? Context window in the sense, it can be a document or it can be a sentence or it can be a whole corpus. Okay. And it's going to help us in between a relationship between the words. Of course, even this is not really more advanced one. Whatever the methods that we have it here are not really advanced except the word to vec and the glove also. We don't use these methods. There are much better alternatives. I'm trying to complete the basic methods. That's the reason I've given it here. Glove is not working in Windows. So what I did is I have used container. I'll explain that. So we need to we can run it in Linux. Something we can use it with Docker desktop, Docker. So covariance basically is going to check every document, every piece of document, like this whole thing, and it's going to check every combination of it. In this case, what we try to do is, let's consider two windows, right? We are given two size windows. It is a off level kind of, it's going to move like that. It's
So
like a
bigram
sliding.
and trigram, that's it, right? That is a window size.
Yeah, right. But it's like it's going to move, process one after another. And if it is three, it's going to be three words. So what we are trying to do is whether it's going to be the same or not, how many times it got repeated. You can see that these are the column names we got, and is weather. So weather, flower, weather and flower been. I think there is some is been given here. So when we provide is, it's not just in not to repeat, no occur immediately. That's like weather nice. Uh, weather and weather and flower, right? So weather and yeah, ease and weather, I think this is. Yeah, ease, weather and ease. You can see that it got occurred once. And then weather and flower, zero. Flower, the, zero. The, it, the, and it should not be. For some reason, I got is weather. We have taken window 2. I don't know how much is they have given. I think window size +1. Yeah, they have given 3. So the is of 3 and 3 in the sense it should not be the exact immediate word. And is okay. Weather flower. Weather is okay. So weather flower obviously is not there. Flower the it's not there. And the it. Okay, looks okay. The problem is that it is going to combine everything into one, and this is going to be the window. So is weather. So it's going to start with is, and then is weather, weather flower, flower the. It's going to occur or not immediately. So the it and it nice. So it's a very old one, and is the whole idea is to understand the words that have been repeated multiple times, so that it's going to find out the relation. And word to vec is much better. Basically, the word to vec is I think initially been brought by the Google, I think, if I'm not wrong. What they did is they have taken a lot of millions of rows of data. I mean to say millions of grams of data, and they created an array. For every word, it's going to have an array. So you can see the flower, it is complete array. I'll explain this in attention. Let me explain this with an example. I don't know where I have that. Not here. Not yet. Okay, maybe later I need to find out where the attention part is. Okay, I will explain this part later. So it's basically for every word it's going to create this thing. Suppose if I have the word hi, hello, and let's take museum, right? Let's say hi will have an array of words. It can be one-dimensional or multi-dimensional, whatever. In this case, it's just one-dimensional, right? It can be even multi-dimensional. And how will have another array? It can be one-dimensional multi. So it's going to have multiple values.
So what are the values denoting that?
So, okay, that's what I'm trying to explain. So here's a museum. Another will have another set of rows. Okay, like val1, val2, val3, whatever. So when we plot it, scatter plot, right? When you plot this data, it's going to come like this. So it's basically multidimensional. Just imagine this way, that there's a hi and hello, and museum is going to be somewhere here based on the data that we provide. Its values there is. So it will make sure that the hi and hello in nearest words, right? This will have the same set of values near to it. There will be some slight change here and there to this one. So it's going to come near. Whereas when it comes to museum, it's totally different word, right? It's not related to hi and how. Sorry, hi and hello. Hi and hello.
Based on the similarities.
Based on similarities, exactly. So it's not just one word, right? It's going to be millions of words. So it's going to prepare that arrays. That's the idea of word to vector. Word to vector. That's the idea of this one. There's nothing but parameters. So when they train with millions of words, and it's going to be a bunch of parameters, and these are the parameters that they came up with. Even in the case of, let's take that we have taken French data. Let's take this English and this French, and let's take hi and something like in French it is hello or bonjour. Like in Germany it is bonjour, right? So bonjour like and hi are going to be this. It's going to be nearby. So when we do machine learning translations, it's going to find out the nearest word that is in French category. The French, all the words are going to be in different dimension, and this is going to be in different dimensions. So whatever the cluster that's nearby, it is going to pick that word. Got it? And it's not possible to draw in this picture. Basically, it's multi-dimensional. We can draw up to 3-dimensional, but we can't draw multi-dimensional, right? That's how this machine translation and all works. And right now we are more relying on open AI embeddings, and not even word to vec.
What is that parameters minimum work? I mean, some minimum count and workers.
Where is that? Which one you are pointing to?
Yeah, in that one, word to vec, there is minimum count is equal to 1 and workers is equal to 4.
Oh, vector size. Vector size, I am interested at 10 values.
After that, yeah, minimum count and workers.
I think it should be at least one value, even if the remaining values are going to be 0. Or maybe if it's completely 0, if it's not been there, if it's a particular word not been there, then it's not going to reflect. And I don't know the exact, let me check the about this one. Sentence, of course, vector size 10. Window size is the number of two words, the sliding part of it. Worker size is the number of threads that it has to take to process this. And minimum count, let me cross check it. I think minimum count is the number of words that we have taken. I think the word size, what we have taken here, window is 2, right? At least it has to occur once. Let me cross check it anyway. Minimum count. Minimum count applied. Okay, not this one. Also, minimum frequency are dropped before training occurs. So the relevant context window is the word. What's below the minimum count frequency are dropped before training occurs. Okay. So what does that mean is like the words that occurred only once, right? That will be dropped. Those words will be dropped before
More
we
than
try
one
to.
frequency
Yeah.
of words will be only selected, like,
Yeah,
right?
right. Those words will be selected for this word to vec. Okay, so the next one is glove. Anyway, we are not going to use this one. These are very old methodologies. I will explain in a LangChain how to practically, apply on OpenAI and to get the embeddings and store it in vector database. It's more minimal in nature. Right now, the glove library is not working in Windows. What I did here is Where is it? Part of NLP, of course. NLP 2. Yeah, here it is. I created cloud test. This one, wherein you need to open the terminal. Here you have Docker file, right? Let me open it in Visual Studio, Visual Code. Here you have Docker file. Basically, it installs Glove in Linux and then run the Python app.py. Python app.py is basically runs Glove against this data and give us the output. Okay, so let me build it first. So commands I have given it here, what has to be executed. It's going to create an image, Docker image. Based on this Docker file. Okay. And this basically comes from Docker Hub. If you look at this Docker Hub, we'll have a bunch of Docker images. Python, right? So let's search for Python. I can see Python. You'll get every image is basically kind of blueprint with some set of instructions, right? The image is basically like, Docker container is all about a mini OS, Linux OS, plus application dependencies. Why we need that? Suppose when we have dev machine, staging, production, so, you might have heard this issue quite frequently, that something that worked in dev machine did not work in stage, even though I copied the same files. Because the dependencies that related to OS dependencies, some software that has been there in development, not been there here. It can be OS dependencies, right? Or it can be application dependencies. So the one that we have it in dev may not be there in stage, or the one that we have it in stage may not be there in production. Something that worked in one mission, some didn't work in another mission. So what they brought in is like they came up with these Docker containers. So this is like a blueprint, This we call it as image. We need to build it, and then thereafter we can create containers. Container in the sense the actual VM. I mean to say it's like a mini VM. The Linux OS will run it. You can see this got created. If you look at Docker images, it's going to list out here, cloud image. That's the image that I have created, right? If you look at this one, this is the name that is reflecting here. And thereafter, this Docker PS will list out containers. As I told you before, it's not reflecting here because Docker PS-A, it started and it got ended. So -A is basically gives us even stop containers. It is not even, it ran and immediately it got completed. Now, if you want to know what exactly this has, Docker logs, and you need to provide the ID. Sorry for that. You need to provide, double click on it, right click. You not to provide, you can provide the complete ID, or else you can provide even the first 2 characters or 3 characters, as long as it's unique. Suppose if you have more than one thing, then it's going to create a problem. So I'm executing, yeah. So if we have another container that starts with 9D, then it will not work. So make sure that you give, as long as it's possible, make sure that it's unique and give the ID as long as it's unique. So 9D here, you can see that the output we got here is the cloud output. It got executed 3,000 times. Look at this one, I executed 3,000 epochs. Number of threads 4. Verbose true because it's giving the verbose part. I mean to say the epoch 1, epoch 2, and 3 and all. This corpus.matrix comes from this one, right? Glove, wherein we need to convert it, the current sentences are given Windows size 5. We don't really require, in this particular case, we don't really require 5. It can be even 2. And then it's going to, once we got this glove matrix, we can display it. So this is how we can display it along with the column names. The column names comes from, comes from this one, dictionary keys, whereas the actual data is from word vectors. We combine together into data frame and shown up here. Okay. Anyway, don't worry. Try to execute this once. Don't worry if you don't understand it, because we have practical production approach is totally different. But I hope you got an idea, right? So each word basically convert into a proper number. Initially start with count factorizer, call it as bag of words, and thereafter TF-IDF factorizer, and then co-occurrence, and then O2vec, and then glove, and then now it's more of OpenAI or any other. Let's take Google, if they provide any embeddings, we're going to use that one. We can have something called tokenizer. If you go to Hugging Face, if you take any model, right? If we go to models, huggingface.co, click on models. Let's take any model you take, click on files and versions. You can see tokenizer. So when we provide input data, this tokenizer, which is nothing but this one, this one. So it's going to, let me open. What is the tokenizer? So whatever this model is going to be, the same tokenizer. Here I have written model, maybe the right word is tokenizer. So they provide the tokenizer. That is how Hugging Face is going to utilize. I mean, is going to give us. How do we
We
make
don't
utilize? Yeah, go ahead.
we don't want to use that word to vec, just like that Hugging Face. What you told, we have to use that one.
Yeah, basically what they did is like they create an object. So we that's an old word to vec is a very old methodology. So for every model, they come with tokenizer. We can directly load up from there. You can see that in this case, I have loaded from this one. So auto tokenizer directly from this path. So what is the path I given? Okay, this is a fine-tuned model. This is the right one. Yeah, this is the right script. I given the model name. Where I got this model? From Hugging Face. If you go to Hugging Face, yeah, you can go to models and paste it here, enter. You can see that this is the model that I got. And if you go to files and versions, it's going to download bunch of information. You can see, what do you call it? As tokenizer, right? Configuration. So it's tokenizer depends on configuration. This file. And this all got downloaded right here itself. And this one I have saved it. The actual model I haven't saved, but this model I have the fine-tuned model I have saved. You can see tokenizer.json, tokenizer underscore config.json, right? So the tokenizer, we don't really this got better. I mean, this got changed. The whole process flow, the whole structure got changed. Earlier we used to do this. Now when it comes to Hugging Face, we can directly use this one, or else you can use OpenAI embeddings, wherein we can directly access the API and convert that text to the respective numbers. Go through this. No, even you haven't, you not to try this one, but at least understand that it got evolved in this way, and later on this one. But this again, this will come at the end of the course. I want to combine both the batches, both 7:30 and 9 a.m. batch. On 31st, we'll plan a deployment session. 31st and 1, or basically I need it on weekends, 31st and 1. Okay. Wherein we are going to discuss like how to deploy it in real-time production, how to manage the cluster and all, both in Azure, AWS, and GCP. And I will explain, like the session starts at 7:30 a.m. IST. Okay. And the meeting ID will be, I will communicate to Ashok IT. So they will share a common meeting ID to both of you. And this script, I will explain this later. So don't worry if you don't understand this. Basically, for different categories, for question answer, or text classification, text generation, for everything I have created one. So in real time, you not to bother about you know applying the model. You can directly use the script. Even fine-tuning part in the sense, when let's take that that whatever the project that you work for, they have their own data. The model does not fit well. Then you can directly use that one, and you can use for everything, for every topic that I have given fine-tuning part also. This is the fine-tuning part, and this is even quantization. Quantization in the sense, once we let's take that model is 1 GB model, right? So once we have that model, it may not be possible to deploy it in production. You need to reduce the size of it. You can use something called quantization. So you can directly blindly take the model and execute it. You can blindly execute this code. So you don't have to search anywhere else. And this like almost completed. There are a few topics. Token classification is pending. Apart from it, everything got completed. Text generation, text classification, everything is good. And if we can test it if you want. So text generation and predict it. Text generation, suppose if we give some text, then it's going to give us the complete text part of it. This is not text generation. Oh, this is text generation. Now, how it got wrong. Okay, I need to cross check this anyway. Let me take summarization. At least this works. So you can see that I have given a lot of data, text data. It's going to summarize it. So you can see original text, this one, and it's going to summarize to this one. So I have a different set of models, virtual model, fine-tuned model. In fact, this is not virtual model, fine-tuned model. This is quantized int age. This FE16 and BF16, brain F16. And the way it works, you can choose any of the models. It's all got saved right in this one. It's a quantized models. You can see that we have saved tensors. That's the model. And here we have the save. Yes, that's the model name. And the remaining are all companion files to this one to convert text to the respective numbers. All right. So this script, don't worry about this. Like go through the scripts, this one. And a glove part may be a bit difficult, but I have given the commands right under this glove test. Go through that and follow the video. Don't worry about, okay, so you can remove it at the end. So let me show you how to remove it. Already shown you, right? We don't have Docker PS So remove it. If you want to remove the container, Docker PS will give us the container, whereas Docker PS will give us the running containers. If it got stopped, it's going to, we need to add -a to get that stopped containers. If you want to remove it, Docker RM and the ID. What is the ID here? 9DCF there. So I'm giving only the first two characters. And then we have Docker images also, right? Let me remove the Docker images. Docker RMI. So now in order to remove the Docker container, it is RM. Remove image, it is RMI. It is a glove image, right? So this one, what is the ID? A50 something. So it's not conflicting with any other ID. A5, there is no such thing as A, starts with A5. I can simply write A5. If you go back and the images, -a, you're not going to find anything. And the one that is showing up in the images, there's a different thing for morning batch deployment, mini deployment kind of. Okay, any questions in today's session? We have discussed latent Dirichlet analysis, that is one, and non-negative matrix factorization, word embeddings, right? And what else we discussed? Yeah, that's all. So this script, don't worry. So I will explain this later. This is the real-time scripts. So you can directly use the scripts in your real-time environment.
So after regular expression, you haven't shared the scripts that.
Didn't I? So let me cross-check it. I thought I already shared all of it.
NLP and NLP basics too. That's it. I have shared.
Oh, I thought that I already shared to you. So 9 a.m., right? Okay. So you don't find, you haven't got here, I think. I think this one is part of NLP3, right? Okay, I'll share this folder. Already have it in Drive, so I'll share it. I need to add your email IDs. That's all. So we need to complete database. There is one topic we have, and the scripts. These scripts I have. What else we have?
Cloud, about cloud.
Yeah, that is comes on deployment. The 31st and 1. Cloud part will come later. Then 31st, August 31st. And first, we'll see how to deploy it in there in cloud, how to manage the cluster. Yeah, quantization is basically part of this one itself. Quantization. We will have projects like once we complete this part, deployment part, we'll go to the Excel, Power BI, and Tableau. So I need to decide whether this week, the next week, or after the final, 31st first session. This will take one session. That's all. And LM file tuning is going to be here. Quantitation again, this is going to be here. The LangChain basics we will complete this week or next week. Database will complete this week or next week. Docker will complete either this week or next week. I will complete in this week itself. We'll complete all these topics in this week itself. And
So these are all NLP topics is completed.
yeah, NLP topics. So these are all topics that we have. So this all comes under NLP itself. So how to take a model directly from Hugging Face and how to utilize it. There is another one, a LangChain. How to combine LangChain so that we can build applications. We can build a whole application like chatbots and all, and directly deploy it. You can use LangChains to build LangChain. The ranks basically this we're going to rely on this LangChain principle framework. So again, that's going to be part of deployment. So we need to focus on these topics this week and next week. And vector database also is going to be part of this one. All right. It's more generative AI, right? So if you look at the kind of problems, you're going to match up with this one. At least most of the problems I covered it. If you look at Hugging Face, models, most of the problems been covered. Maybe one or two, but exempted, but the remaining all same. Text-to-text generation. All right. Tomorrow, I will take databases. Maybe that is the topic that is pending. Or maybe Docker and databases. Databases will take a whole session. Yeah, the next two sessions are going to be on these three topics. All right, that's it for today. We'll continue tomorrow.
So NLP topics are most of the topics are done, right?
Yeah, most of the topics are done. But when it comes to real time, we have, whatever the basics that we have discussed till now, we're not going to use it as it is. But these scripts that I'm preparing it now, like this, the one that we are going to deploy, these are the scripts that you have to utilize in real time. not the one. So unless we start with the basic one, it's not possible directly jump to this one. So you'll have difficulty to understand it. That is my point.
Sir, this tip means how we can use the existing model for that.
Yeah, exactly. So LLM model is not easy to train. It requires millions and billions of dollars. So what they did is the Hugging Face is basically a hub wherein you'll get free models. The size even there are some 400, you can see 7B models, right? I don't know whether I explained this or not. So we have something called LM Studio, wherein you can experiment these models. Suppose I can search for any model I want. For example, Llama. I'm going to get all the models that are, you can see that 7 billion, whatever. You can directly download it. Click on download, that's all. And how to utilize it? So you can click on this chat, and then you need to, once you download it, it's going to reflect here. Let's take
Sir, what is the software name, sir? This is
LM Studio. Don't worry, I will explain this anyway later. LM Studio. You can download this. Download if you're using Mac, check M1, M2, M3 versions. And this is for Windows. I have downloaded Windows version. This is for Linux. So I hope you got the point, right? So go to home, search for the model, or utilize the models that you have it in the dashboard. Once you download it, so you don't find any option download here. You already download it. When you need to click on download, and then or else you can search it here. Or if you click on search, it is going to move here, directly to move here. I'm going to download it. And then you need to move to chat and attach the model. Let's take that I want to attach this Metal Llama 3.1 instructor take 2, and the size is 4.92.
sir, it will download to my local machine, sir. This one.
It's going to
Download to my machine. This one.
It's already downloaded in my machine. So you need to download here. So you need to search here and you need to click on download. And this chart is basically to attach the downloaded model. I already attached it. You can see download model. If you want to eject it, you need to click on eject. Otherwise, this is going to occupy the GPU space. So if you don't have GPU, don't try this. You can try the basic models, but don't try large models. Let me attach this back again. If you go to task manager and performance, you can see that it has occupied something 10 GB, right? And then you can see spikes here and there. Okay, now you can start charting it. For example, give me some question like so that I can answer and try to question this chatbot. What do you want to know? Any topic you want, something like technical. It's 4.5.
Like related to AI itself, you can ask the
Yeah,
question.
go ahead. What is the question?
Yeah, related to AI itself, like what is AI and all, you can just ask the question, right?
Okay, what is generative AI? This is basically LM Studio, right? It's a Windows application. Whereas we can use LangChain with Gradio or Streamlight and can build a similar application like this. Web application, we can build it.
So will there be sessions on Hugging Face so that we're
Yeah,
familiar?
we'll have a session on that. So once we complete LangChain basics, Docker, and that the other topic, databases, we'll move on to this one.
Will our chatbot project be like this, the interaction like that?
So it's going to be more like like this. It's going to be in LangChain, not in this phase. Basically, we provide some input and we get the output. So the way we need to provide this input is going to be, so it's going to, we need to process it. So we need to build the whole thing. Let me show you that. For example, once we have these files, right? Full mass predict. This is basically for prediction, isn't it? We provide some input and it's going to find out the mass. What is the mask here? Kepler Francis, methyl is something. And this need to be wrapped in Docker file. And even before that, we need app.py. This way it's going to send the request. So when it mentions local, whatever the IP, the host name / predict is going to take the output and process it, and it's going to give us the output. So we need to run it inside the container. That's how it works. So we need to understand the basics first, Docker and this part, then can move on to that one.
So do you have to create app and all later? I mean, using
Yeah,
Flask
so
and
you need to use Flask. But I will tell you a shortcut, so don't worry about how to create this.
yeah. Okay.
You can use generative AI itself, right? And what I will explain what need to be provided so that you can have this API. Of course, don't expect that it is going to be 100%. Okay, you got this one, right? Okay, and you got the output. What is generative AI? It is giving the output. Give me one practical implementation of generative AI, like text, some text generation using Hugging Face model and transformers library using Python. Okay. I start giving instructions. It's even giving me their code. Of course, if this need to be the right model. There are models specifically for Python coding. Either you can use this one or use that or this one. You can see that it is, using this models, TF basis, even coming up with its own basic model. If you execute this, it's going to work. Let me take this code. Okay. And I'm going to, okay, test folder, test.py. Maybe I rename it to Jupyter Notebook is quite easy to see the output. And I'm going to change the kernel. This is my virtual environment. I'll explain that. I'm going to execute this one. It's going to download and it's going to generate text. You can see it's even downloading tokenizer, right? And now this is the model. Model can be .bin or .pt or .pth or .safe tensors, .pickle or .h5. The model comes with different file formats. The safe tensor, the Hugging Face mostly use safe tensors because it's more secure. Right now, this is downloading the model, this TF we can change to another model altogether. You can go to here, Hugging Face, and let's take this text generation, right? Click on models and text generation. You can pick any model you want. You can even see 405 billion parameters. It's not going to fit in my machine, at least. You can see the smaller one you can pick. In this case, it's a small one. Okay, so it's giving the short story about the character who discovers a hidden wall. Yeah, about a cat who discovers. Okay, is it completed? Okay, that is the generate story. That's all. It is giving a very short one. Max length 6,000. It's still giving me the same thing. What about minimum length? 100 at least. There's something as minimal length. All right. So do one thing. Take another one. Let me copy this. But this is definitely going to be a bit huge. Tokenizer because it is Lama, but okay, so I will do one thing. Auto tokenizer and this auto model for I think it's causal LM. Can't access gated. Oh, okay, this is a gated one. So I need to, you must authenticate it. Okay. I can't directly access it. Let's try that. Uh, this is a gated one. So that's what it says. I need to log in and all. So I don't want to gated come model. We need to permission for this. We will pick another one. Even Google models are mostly, I don't know the file size of this. What is this? 4, oh, it's too huge. Around 20 or something, 20 GB. Okay, this looks promising, 8 billion. And 4, oh, even this one also huge, around 15 GB. Okay, we'll do one thing. We'll search for a small, which is still under text generation. So let me take this one. Uh, I hope this gives a better result. If a base is not giving the good result. Okay. Here we have file name config.gsm. Oh, they completely missed the config.jsm. This is a very poor one. So let me take better model. Model name. So instead of copying it twice. At least they start working, whatever the code that we got here. That's right, we copy and paste it. But it's not going to work in all the cases. So we need to, it may have some bugs. In this case, I have created a very good virtual environment that's going to use even the Coda. If you look at this, start using GPU even for inference. In this case, you can see that the model is .bin. I hope this will give a better output at least now. You can see the attention mask, okay, attention is not set and can't be informed. Ask the pad token if you're not set as sequence, you may observe unexpected behavior. Okay, that's fine. Oh, this is still executing. This is a sudden high spikes here. Still has to give me the output. Basically, we are trying to capture this. You can see that this is the output that it got. And it is not giving the right output because the model is not good. But it is giving 1,000 words or whatever, trying to fit into this one. So in order to have better model, we can have better models, but the problem is that we need to have good amount of GPUs. So what I did here is text generation, right? This is, yeah, so text generation, I have picked a better model. Where is the question answer, text generation. And predict part, it's completely has gone wrong. Okay, so basically I combined both zero shot classification and this one. That is when the script gone wrong. So I need to give us something else. This is zero shot classification. So I need to correct few things here, but at the end you will get this one in a couple of days. Maybe by the end of this week you will get to know this.
Okay.
But the thing is that you can only try the base models. When it comes to production, you can try large models. You know how to search it, right, by now. And of course, you have to have good amount of GPU. There are very good models here, as you can see, 405 billion parameters also. Somewhere here, 405 or something, 415. Very large model. Oh, I have given small dash 3 not. You can see that 405 something here, right? You can see 405 billion parameters. Most of it are free, some require authentication, those sort of things. Python versions, you need to cross check it. You can see that there are many. At least it could be so 80 GB at least this one, if I'm not wrong. More size is around, what is the size of it? Yeah, it could definitely 70 to 80 GB. Not less than that. All right. Any questions in today's session?
No,